Okay, so what we're wanting to do is calculate the mole fraction of a 30% hydrogen peroxide solution. So, wrong button there. We want to turn that percent, since it's assumed to be a mass percent, into an actual mass. So we're going to assume we have 30 grams of hydrogen peroxide to every 100 grams of solution. But since this is a mole fraction, I actually don't want mass of solution on the bottom. I want the mass of the individual components. So it's 30 grams of hydrogen peroxide and 70 grams of water. And I'm going to convert these into moles. So I need to get the molecular weight of hydrogen peroxide, which is 34.02 grams. I'm going to do that same thing down here again because I want moles in a mole fraction calculation. And I'm going to need 1 mole of water is 18.016 or 2 grams. All right, now the trick that throws everybody off is how we're going to put this into the calculator. So I'm going to take advantage of parentheses to do this, right? Move this calculator over here. So we're going to do the top first, 30 divided by 34.02. And I'm going to divide this number by, well, I need that number again, but I also need to add. I'm going to make sure I get this right, so I'm going to use another set of parentheses, 70 divided by 18.016, and close both sets of those parentheses, and get my answer. Now typically any mess up on the calculation occurs when you're messing up that bottom number. So there's absolutely no reason why I couldn't have actually taken that 0.881 I got there and just said, well, this is 0.881, this is 0.881, and then I will just, instead of throwing that into the calculator, follow those parentheses. Let's just figure out what 70 divided by 18.016 is. And that's 3.8689. And what I could have done is use those values. And might round a little bit different because I've only taken 3 significant figures there, but it's going to be darn close. I'd say that's close enough. I got 0.1849 before 1.846. It'll be accurate enough for how we're doing this. I probably